Hello, I welcome you all to this another interesting screencast. The problems are read if FB is equal to 560 and FC equal to 700 newtons, determine the magnitude and coordinate direction angles of the resultant force acting on the flagpole. In the other case, if FB is equal to 700 newtons and FC equal to 560 newtons, determine the magnitude and coordinate direction angles of the resultant force. Alright, first things first. Of course, basically how you are supposed to solve this, for you to find the magnitude, you need to convert this particular force magnitude into a force vector. So you know to say a force itself will be equal to its magnitude. If you wanted to convert it into a force vector times that particular unit vector in that direction. Alright, and you know to say the unit vector is just equal to the force vector divided by its magnitude, or if you can also have a unit vector equal to the position vector divided by this magnitude. Alright, so basically this is what we intend to do. So I think first and foremost, I'll choose A. I'll say let A be our ref. Therefore A will be 0, 0, 0. If that is the case, therefore our error will say let A be, so our reference, we just say reference, our reference is A, which is 0, 0, 0, and therefore error AC, which is just equal to error C, because A is our reference, will be equal to what are the coordinates in the x direction? It's a 3i. So here we are going to solve this by using both the scalar and the vector analysis methods. 3i, the y is 2j, and then the z is a minus 6k. Okay, therefore its magnitude is just going to be equal to, that's using the Pythagoras theorem, 3 squared plus 2 squared plus 6 squared, root of that is equal to 7. Alright, and then we have RAB, which is also just equal to RB, and this is equal to, in the x component we have a 2i, in the y we have minus j, and z is minus k. The magnitude remains the same, okay, using the Pythagoras theorem. Okay, the numbers are the same. 2 squared plus 3 squared plus 6 squared, square root of the answer is a 7. Okay, so now let's draw these forces here. We can draw them here if you don't mind. So let's start with F. We start with FC. So in the x direction, we expect a component in this direction. Okay, in this direction, you look at the octant where it is. So you have a vector in this direction. Let's not make it longer because we are going to have another one. Okay. Right, so you have that one, and then in the y you are going to have another one like so, and then you are going to have one down like so. Alright, then for FB it will have one component along the x like so, right, then it will have another one along the y like so, and then it will have, maybe this one I make it a bit straight, it will have one along the y like so, and then it will have another one here like so. Right, so let's label these. So FC, this one is FC. Let me start with this. This is FC. This is FC by, this is FC times the run along this direction. Which direction? That along the x-axis. Along the x-axis, it is a 2. Okay, it is a 2. This value or the units is a 2. Where is it? Along the x-axis is a 3. Sorry, we are dealing with we are dealing with FC. This value here. Okay, or this unit here. You've seen this one along the x-axis. So it is a 3 divided by the magnitude 7. Alright, and then this one will be FC times the run along the y-axis, which is a 2 divided by a 7. Then this one is FC times the rise, which is just a 6 divided by a 7. Alright, then this one is FB. The run along this direction is a 2, right? It's a 2, this one. It's a 2 divided by a 7. Okay, let me write it from somewhere there. I lift it a little bit. Okay. So this one is FB times 2 divided by a 7. And this one is FB times the run along the y-axis, which is a 3 divided by a 7. And this one is FB times the rise, but it's going down, 6 divided by a 7. So we have all these components. Usually I like putting them in a table. Let's fit them in a table. You don't have to do this. Okay, that's 1, 3, another 3, another 3 up to somewhere there. So this is for the title. So we have 1, 2, we only have 2 of them, and then let's include 1 for the resultant. Okay, this is 3D, so we expect something like so. Alright, let's fill in. We have force there. This one is FB, this one is FC, and this one is FR. Then the forces are in what are these newtons? So we have the x component in newtons, we have the y component in newtons, and the z component in newtons. As FB component, FB is the one in green in the x direction. FB, what's its magnitude? Of course, there are 2 cases there, so we just write it as it is. So just say FB is 2 divided by 7 FB, and is positive, and the y component is minus 3 divided by 7 FB. The z component is minus 6 divided by FB, and then FC, we have a 3 divided by 7 FC is positive. The y, it is the y, it is 2 divided by 7, and it is positive. And the other one is 6 divided by 7, and it is positive. And then we have the resultant there, which I'll just write as f(x), f(y), and f(z). Alright, so we have f(x) is going to be equal to 2 divided by 7 fb plus 3 divided by 7 fc. fry is going to be equal to minus 3 divided by 7 fb plus 2 divided by 7 fc, and frz is equal to minus 6 divided by 7 fb minus 6 divided by 7 fc. So let's go to the first case, which is case 1, and it's a 2-92. Okay, alright, so now here we have been given what FB is. We've been told FB is equal to 560 newtons and FC is equal to 700 newtons. So I've been asked to determine the magnitude, and we know that the magnitude of the resultant FR, okay, is nothing but equal to the square root of FRX squared plus FRY squared plus FRZ squared. And we have this, so we're just going to plug in. So plug in these values of FP. So say FR magnitude is just going to be equal to, let's plug in, let me move it a little bit, maybe somewhere here. Let's plug in. So this gives us this one is going to be equal to, let's plug in. So we have brackets, I'll say FRX, say 2 divided by 7 times FB, which is a 560 squared, plus this one is 2 divided by 7 by 560 plus 3 divided by 7 by FC, which is 700, is in the squared. Okay, and then we have minus 3 divided by 7 times FB, which is a 560 plus 2 divided by 7 times 700 squared plus negative 6 divided by 7 times 560 minus 6 divided by 7 times 700 squared. Square root of that, then I have this is 1174.56 newtons. Okay, so this is the magnitude. This is the magnitude, but of course we are not yet done. Let me go through again. 2/7 by 560 plus 3/7 by 700 squared plus minus 3/7 times 560 plus 2/7 by 700 squared plus 6/7 by 560. By this one we can factor out, then sum up the two. 6/7 times 560 plus 700 squared square root of that 1174.56. So this is the magnitude. Let's find the directional angles. We know that the unit vector FR is just going to be equal to the first vector itself divided by the magnitude. Okay, so therefore start writing one by one. Cos alpha R is just going to be equal to f r x divided by the magnitude. Okay, therefore you can work out alpha r. Let's just do the calculation. Frx, we know it is 2/7 times 560 plus 3/7 times 700 divided by 1174.56. Cos inverse of that, we get a 66.994. Okay, then cos beta result is just going to be equal to FRY divided by its magnitude. Then this is just going to be equal to, when you do the calculations, we have minus 3/7 by 560 plus 2/7 by 700, everything divided by 1174.56. Cos inverse of that, we get a 91.95. And then finally we have cos gamma R is just going to be equal to FRZ divided by the magnitude of the vector itself. Therefore, gamma R is just going to be equal to minus 6 divided by 7 times 560 plus minus 6/7 times 700 close bracket. Okay, and divided by 1174.56, and cos inverse of that, we have 156.85 degrees. So we are done with the first part. Let's go to the second case. Let's call this as case 2, which is 2-93. 2-93. Alright, there we go. Let me just create a small boundary here, like so, like so. Okay, great. Alright, so now let's work out this. What do we have here? Here we have FB. FB is equal to 700 newtons, and FC is equal to 560. The same values. Or here they just exchange. Alright, they've just swapped the same values. Okay, so what does it mean? What's the magnitude? Does the magnitude change? What's the magnitude here? The magnitude of our resultant, let me see. Okay, I think there will be some changes. Let's work it out. We're using this equation again, the same equation here. Okay, just plugging in two new values. So 2/7 by 700 plus 3/7 times 560 squared plus minus 3/7 times 700 plus 2 over 7 times 560 squared plus minus 6 over 7 times 700. This one will be the same value, 6 over 7 times 560 squared, square root of that. So this doesn't change, right? Why did I have to go through? Okay, so this is the same value, 1174.56 newtons. All right, and then let's now work out the angles. We are using the same equations, this one here, this one there, this one there. So I'll just go down to alpha r, beta r, and gamma r. Okay, I'll not write those equations. So therefore alpha r for this one is just equal to frx. And does anything change again here? So 2 over 7 by 700 plus 3 over 7 by 560 divided by 1174.56. Cos inverse of that, we have a 69.99, which is just a 68.0, or just 68 degrees. So this one changes, of course. Then we have beta result, beta. Okay, what do we have? We have minus 3 over 7 by 700 plus 2 over 7 by 560 divided by 1174.56. Cos inverse of that, this gives us a 96.85 degrees. And then we have gamma result, gamma r. Okay, this is just going to be equal to minus 6 over 7. This one we expect it to remain the same, it won't change. Okay, this one won't change. We don't expect this to change. 5, 6. Cos inverse of that is 156. Yes, we have 156.85. Alright, I think we found everything else. We found the coordinate directional angles. We'll just create a boundary here. Here like this. I usually use one color for boundaries. Okay, so then let's outline the final solutions. In the first case, we have the magnitude of the resultant force, which is of course here, as well as the angles. We have the magnitude there. That's the magnitude. And then we have, of course, this is the magnitude. There we go. Magnitude. Okay. There we go. And then we have in the other case there, the magnitude is the same, of course. And then we have the values of alpha, like so. Right, I think this is about it. I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.